These are the 12.1 Algebra 2 notes covering basic matrix operations. Okay, so first let's discuss what a matrix is. A matrix is a set of numbers arranged in an array. All right, and so basically an array is a format where you have numbers going from left to right and up and down. So kind of like a spreadsheet or columns and rows. So a matrix is written like this. So it has these brackets, and then the letter inside is its name. So how you would say this out loud is you would say matrix A. So A is the name, and then the symbol indicates matrix. All right, when you're talking about the dimensions of a matrix, you always refer to it with its rows first, by its columns second. So for example, if you look at these matrices right down here in A, this has two rows. The rows go across. So rows are going this way. So it has two rows and it has two columns. So this is a 2 by 2 matrices. This is also a 2 by 2 matrices. Let's look at B real quick. This one has, if you look at it, 3 rows and then 2 columns. And so you do rows first, so 3 by 2. This would also be a 3 by 2. All right, down here on C, this one has 2 rows and 3 columns. So remember, rows first, so 2 by 3. And then this is a 2 by 2. Now, it asks to perform the indicated operation, meaning add or subtract, if possible. If not possible, explain why not. All right, and so let's just make ourselves a little note here. And to add or subtract, they must be the same dimension. The matrices must be the same dimensions. All right, so that is the rule. All right, so when we look at this first one on A, it's a 2 by 2, adding with a 2 by 2. So that is possible. And so when we add them, they're going to create another 2 by 2. I'm going to show my work, which I normally don't need you to do, but I just want you to see where this is coming from. So if I show my work on this, I have this first 2 is in the first row, first column, and the 1 is the first row, first column. So you're going to do 2 plus 1. So that number is going to be 3. And so then -1 is in the first row, second column, and so is 2. So you're going to do -1 plus 2. And so that number is going to be 1. All right, and then you have the 3 and the 4 are the second row, first column. So you do 3 plus 4, they're in corresponding locations, so you get 7. And then you do 0 plus -2, and you get -2. And that's what your answer matrix is this 3, 1, 7, -2. Okay, so now if we look at B, B is a 3 by 2 subtracting with a 3 by 2. Since they are the same dimensions, you can subtract them. So once again, I'm going to show you the work, even though I wouldn't necessarily show steps on this if I were doing it. But it's always good to write in your notes so that if you're going back, you can figure out how you got those answers. All right, so the 2 is in the first row, first column, which is the corresponding location to the -1. But keep in mind you're subtracting, so you're doing 2 minus -1, which turns into plus, and you get 3. So then you have -3 and the 2. So you're doing -3 minus 2, which is -5. And you have 5 minus 7. And so that makes -2. And then you have the 4 minus the 8. Like I said, I normally wouldn't show the steps on this, so I would just do it. But just so you can kind of see where it comes from. So then let's see here. If I did the -2 with the -5. So remember, the key is it's subtracting, so don't go too fast and mess that up. It's -2 minus -5. That's like plus. So you get 3. And then the 8 minus 6. So you get 2. So if you notice, the resulting matrices is also 3 by 2. So they have to be the same dimensions to be able to add or subtract, and their answer will also be those dimensions. So looked in here at C, this is not possible to add or subtract. And the reason why is they have different dimensions. Okay, on example 2, they want us to perform the indicated operations. This is multiplying by a 2. A 2, this just number outside, is called a scalar. And so when you're multiplying by a scalar, which is just a number outside, essentially you just distribute it into everything. So you take the 2 times each number inside the matrix. So 2 times 3 is 6, 2 times -2 is -4, 2 times 1 is 2, 2 times 5 is 10, and so on. And that's how you do scalar multiplication. So on 2b, it involves a scalar multiplication and addition. So because there are no parentheses, you're going to start here and you're going to multiply the scalar first. So that's going to give us -15, 0, 6, and -12. All right, and then you still have plus this matrix. And so remember, you add the corresponding locations. And so you have -16, 0 plus 7 is 7, 6 plus 3 is 9, -12 plus 2 is -10. And that's our solution. All right, so solving, this is a 2 by 2 equal a 2 by 2. So each position in the matrices has a corresponding position. And since they are equal, what that means is each one of these that I've color coordinated are equal to each other. So you have A equals 4, B equals -7. On C, you have 2C equals 8. C divide by 2 and you get 4. And on D, you have D plus 4 equals 6. You subtract the 4 and you get that D equals 2. And that's your solutions to example 3. All right, example 4 is the same concept. Now, there is a parentheses right here. And so what that parentheses tells me is I need to do this addition first because it's in the parentheses. So I still have the 4 scalar multiplication outside. I'm going to do -2a plus 3. 5 plus -6 is -1. -4 plus 7c. And 2 plus 1 is 3. And it still equals this. Okay. So to keep going, I need to multiply by the 4. So when I multiply by the 4, I am taking, do it up here, 4 times -2a plus 3. So that is going to get me -8a plus 12. You have to distribute it. And then 4 times -1 is -4. And then I'm doing 4 times -4 plus 7c. So just distribute that and you get -16 plus 28c. And then 4 times 3 is 12. All right, and so just like last time, we're going to set the corresponding parts equal to each other. So I'm going to put -8a plus 12 equal to -28. -4 equals b. -16 plus 28c is equal to 40. And 12 is equal to d. So then I'm just going to solve those real quick. All right, so I'm going to subtract the 12, and that will get me -40. So A is 5 when you divide by -8. Let's see here. On B, I just have that B equals -4. On C, I have to do -16 plus 28C equals 40. And so I end up solving that and I get C equals 2. And D is equal to 12. So there's all my solutions, and that's how I came about it. Okay, on example 5, a high school district track and field organization used the same standard qualifying times for its district championships in 2 consecutive years. The tables show the numbers of boys and girls in 3 class levels who qualified in the 100-meter run in those years. Organize the data, here's where it says, using 2 matrices, 1 for each year. So right there, they told me how they want the data organized. So I'm going to make a matrix A for the first year, which was 2019. And then I'm going to make a matrix B for 2020. Now, if I'm doing 2019 and you look at these numbers, these are the numbers for 2019. And so let's say I put the 18, 23, and 16 first. That's the boys column. So in that case, I'm putting the boys first and therefore the girls second. It doesn't matter which you do, but here's the thing. Once you've set that order, when you go to the 2020 matrix, if I did boys first, I need to still do boys first. I can't switch all of a sudden. So because I set that order for the 2020 matrix, I have to do the boys first, which is 16, 25, 12. And then on the girls, it's 15, 18, 18. So there's your two matrices. It says, find and interpret a matrix that gives the average number of boys and girls who qualified in each class. So to find the average number, you're going to add them up and divide by how many years. So basically, you're going to take matrix A plus matrix B, and then you're going to take that answer and divide by 2. So I'm just going to put multiply by 1/2. All right, so let's go ahead and do that. So I'm going to keep the 1/2 out here. Let's start with doing A plus B. So I'm just going to add these up real quick. 18 plus 16, 21 plus 15, and so on. Go ahead and pause and add the two matrices together. All right, so I added all those numbers together. Now let's half each one. So that's 17, 18, that'd be 24, this would be 20, 14, and 21. I just halved each number because I was doing this scalar. So that is the average number of boys and girls who qualified in each class. Now it does want me to interpret, so let me just give you an example of one of them. Let's just do 17. 17 is in the boys column, and it's in class 1. So you have the boys column, you have the girls column, class 1, 2, and 3. And the classes are just like the same concept of like 1A, 2A, 3A, 4A, like sizes of schools. So if we just try to interpret the 17 as an example, it means that an average of 17 boys in class 1 qualified between 2019 and 2020. So like if you did 18, it'd mean an average of 18 girls qualified in class 1 between 2019 and 2020. And that's how you would interpret it.